This limit needs to be tackled with the squeeze theorem. Now what clues me into the squeeze theorem? It's this cosine of 2 over x term. Normally we see nice pretty cosine terms like cosine of x or cosine of 2x. But anytime I see cosine of 2 over x or even sine of 1 over x squared, something funky with an x in the denominator, that clues me in that squeeze theorem is probably going to be used here. So in order to tackle this problem, I'm going to start with a fact. That cosine or sine, whichever one, those two functions always exist between -1 and 1. This is true whether you're talking about cosine of x or cosine of 2x or cosine of 2 over x or cosine of Miley Cyrus. It doesn't matter what's inside here, it's always between -1 and 1. The next step is function. We need to make this guy look like this guy. So what I'm going to do to this inequality is multiply all sides of this inequality by x to the 5th. That's going to give me -x to the 5th, x to the 5th cosine of 2 over x, and then I have x to the 5th over here. The last step is limit. So what we're going to do is we're going to take the limit as x approaches 0 of the endpoints of this inequality. I'm not going to worry about this guy in the middle. You'll see what happens in a minute. But I'm going to take the limit as x approaches 0 of this piece and of this piece. That's pretty easy because all I need to do is plug in 0. So when I plug in 0 for this, I get 0. And when I plug in 0 over here, I get 0. So where must this guy go? Well, it's squeezed, hence squeeze theorem. It's squeezed between the values of 0 and 0. And the only number that I can think of that exists between 0 and 0 is 0. And so that makes your answer to this question 0.